Let's do case 6 time conversion. First, we have convert 300 hours to seconds. Now, we have to write our conversion factors, and that is for every 1 hour, we have here 60 minutes, and for every 1 minute, we have 60 seconds. So, we have 300 hours to second. So let me write 300 hours times, we all know that we have to put here 1 hour and then 60 minutes, and then for every 1 minute I could have here 60 seconds. So we're now ready to cancel the unit, hours to hours, minutes to minutes, and that is 300 times 60 times 60. So we have 300 times 60 times 60. Let me press that in my calculator, and that is 1,080,000 seconds. Now, we could simply convert it into scientific notation, and that is 1.08 times 10 raised to, let me count first, 1, 2, 3, 4, 5, 6. And that is times 10 raised to 6. Sorry for that. Seconds. And therefore, this is not my final answer, because on my given, I only have one significant figure. So I need to round off my answer into one significant figure, and that is simply 1 times 10 raised to 6 seconds. One significant figure. Okay, next. This time, I have to convert 134,789 seconds to days. Let me write my given. 134,789 seconds. Now, what are my conversion factors? These are my conversion factor. So, I have for every 1 day, I have 24 hours. For every 1 hour, I have 60 minutes. And for every 1 minute, I have 60 seconds. Now, as you can see, I already listed my units in my conversion factor. If I have my seconds, I listed here my seconds, and if I have days, I have here my day. So, that is, let me now use my dimension analysis. So we have here 60 seconds. I write this 60 seconds here at the bottom part because my goal is to cancel the second. So I have here 60 seconds and then 1 minute times, I have here 60 minutes. So I will write here 60 minutes because my goal is to cancel the minute, and then 1 hour, and then have here 24 hours, and then I have here 1 day. Okay, so I'm now ready. What I'm going to do here is to simply press it in calculator properly. So what I'm going to do, so if you're gonna press it in calculator, press first 134,789, and then press divided by 60. Okay, so let me do that. 134,789 divided by 60. Press equals. Now don't forget to press equals. And then after that, press divide. 60. And then press equals. And then after that, press divided by 24. And then press equals. Okay? So that's how you're gonna press it in your calculator. So that's the proper way, because if you do it like 134,789 divided by 16 and divided by 60 divided by 24 hours, then that will be wrong. You must first press equals for every after calculations. So our answer here is 1.56 days. Okay, now, so how many significant figure do we have? 1, 2, 3, 4, 5, 6. So we have 6 significant figure. So I may round it off to, or simply have a number with more significant figure, and that is 1.56 0, 6. 1, 2, 3, 4, 5, 6. Okay, days. Unless your teacher instructed you to round it off to 2 decimal places, then this one will be fine. But if your teacher says it depends on the given significant unit, then therefore this will be the final answer. So our case 7 would be speed conversion. So we're now on the last case. So we have here the speed limit is 80 km per hour. Convert this into meter per second. What we're going to do? 80 km per hour. So from here we have now, let me write first my given. This could be expressed as 80 km over 1 hour or R. My goal here is to simply convert this kilometer into meter and R into simply second. So what are my dimension? That for every 1 kilometer, that is 10 raised to 3 meter. Okay? And let me convert my R into second. Okay? I have here my 1 hour, that is 60 minutes, and I also have 1 minute into 60 seconds. So let me now solve the problem. My first thing that I need to do is to simply convert this kilometer into meter. So let me have this as blue ink, and the other one would be the red ink. Okay, so I have here, my goal is to convert first my kilometer. I'll write 1 kilometer at the bottom, and then 3 meter on top. Next, this time I have to convert my time. So we have here 1 hour. So let me correct this 1 hour. Okay, so 1 hour, I'll write my 1 hour here. Sorry for that. I'll write my 1 hour here at the top because I simply want to cancel, and then 60 minutes below. Why do I write here R on the top? Simply because I need to cancel this R. R is on the bottom, and I will write R on the top here, and then my kilometer, and then kilometer. Next, since I want to express it in seconds, I have here 1 minute and then 60 seconds. So I could now cancel the unit of minutes. So that is simply 80 times 10 raised to 3, and then divide it by, press equals in the calculator. Okay, so we have here 80 times 10 raised to 3, and then press it in the calculator, and then press equals, and then press divided by 60, and then press equals, and then after that again press divided by 60 and press equals. And so we have here final answer, that is 22.22. What is our unit now? Our unit now is meter per second. So our unit now here is meter per second. Converting it to proper significant digits, we have one significant figure. So we have 1 SF, and then therefore our final answer would be 20 meter per second. One significant figure. Next, the average jogging speed is 1.5 meter per second. Convert this into kilometer per hour. So, let me write my solution now. So, 1.5 meter per second. This 1.5 meter per second, remember that you could write it properly like this. So we have 1.5 meter per second for you not to be confused. And then times, so my goal here is to simply convert meter into kilometer. And then therefore, I'll use red ink. And that is 10 raised to 3 meter, 1 kilometer. Based on my conversion factor. Okay, this is my conversion factor. And then I'll use red ink for the time. So since this is my second, I will write here 60 seconds because I want to cancel then 1 minute, and then 60 minutes, and then 1 hour. Cancel with minute. And then therefore I have here 5.4 kilometer per hour. There's two significant figure. Now, how about this special unit? The special unit we have we have to take note that 1 centimeter cube is equals to 1 cc and is equals to 1000 ml, or 1 liter we could have 1000 ml, or this just equal to 1 liter is equals to 1 decimeter cube. Take note of that. Now, let's try to have this. The density of pure water is 1 gram per cc. Convert this unit into kilograms per liter. So, the thing here is, these are factors. Remember that 1 kilogram, let me write my conversion unit or conversion factor. 1 kilogram, that is 10 raised to 3 grams. And then 1 cc, that is just same as 1 centimeter cube. Okay, and then 1 centimeter cube is just equal to 1 ml. Okay, and then 1000 ml equals to 1 liter. So we have here 1 gram per cc. So my goal here is to simply convert these grams into kilograms. We have here 10 raised to 3 grams and then 1 kilogram. And I could simply cancel this unit. And then after that, convert this cc into liter. So we're going to put my 1 cc. 1 cc here. That is 1 cc and then 1 ml. So 1 cc, 1 ml times 1000 ml 1 liter. And then therefore, I could now cancel the unit. I have cc, cc, and then ml, ml. So the unit now is kilogram per liter. So therefore, therefore we have 10 raised to 3. 10 raised to 3 is just the same as 1000. And then therefore, as you can see, I could cancel my 1000 here. So cancel, cancel. And then therefore, I could say that that is 1. The unit is 1 kilogram per liter. So in terms of density, we have 1 gram per cc is just equal to 1 kilogram per liter. Or, let's say for example, my density is 2 grams per ml. That is just the same as 2 kilogram per liter. And that's it. Thank you for listening.